All
Okay,
right.
yes, that is
That's it.
that. Okay, I will
Excellent.
also close my video. So it's all your floor.
Thank you very much, Rosaria, and thank you everyone for being here. It's really a pleasure to be with you as I bring you on this little trip across the Eclipse IoT and Edge ecosystem. Now, as far as questions go, please feel free to ask them as we go. I think I've got some materials, and we've got some time to cover it all, I think. And in any case, I will speed up towards the end if that's needed. So feel free to jump in whenever you feel like it, really, with your questions. And of course, the slides will be available after the broadcast. Every deck that we do at Eclipse are really publicly available and published under Creative Commons licenses. So feel free not only to look at them after the broadcast, but really, if some of the materials are of interest to you, you can use that in your own decks, of course, by providing attribution to the Eclipse Foundation. So I'm Frédéric. I have the pleasure to manage IoT and edge computing programs at the Eclipse Foundation. And really, I've been around the industry from this point. And really, you can find me on social media if you are so inclined. So I'm on Twitter as Blueberry Coder. I'm on Mastodon as well. I forgot to include the ID on this particular slide, but it was on the cover slide. And you can find me on LinkedIn. So feel free to connect and to continue the conversation after the broadcast. If there's anything that I can help you with. And well, the thing is, today we have roughly an hour to cover the thing, but if you are more into reading, or if you want to have a deeper dive about what we'll cover today, at least most of the stuff that we'll cover today, then I wrote a book. It's been available since December 2022. And really, it's using the same structure as this presentation, with chapters, roughly in the same order, and using the same framing device, the same framing IoT and edge architecture. So if you want to go a bit deeper, that's a good source to use, and it's available worldwide. But if for whatever reason you are having trouble finding it in your country, I can help out with that as well. All right, and everyone on this call is certainly aware of what Eclipse is and what we are doing. But I left this slide in because really one thing that we have to emphasize at this point is that Eclipse has been doing many other things than development tools for quite a long time at this point. And in fact, the Eclipse IoT Working Group is the first working group ever created at the Eclipse Foundation. It's been around since 2011. So at this point, we are getting closer and closer to our 12th anniversary. And all of that to say that what I'm presenting today is not a brand new thing, that's been around only for 6 months that you cannot count on. This is literally the most mature non-development tools community at Eclipse. And really, IoT and edge computing are one of the 4 strategic pillars that we have at the foundation. So of course, development tools are still around, and development tools are still something that we invest heavily in, but really there's much more than that. And IoT and edge computing is one of the 4 strategic pillars that we have. So this is not a sideline for us. This is really part of the core value that we bring to the open source community. So one very important thing, and since most of the people on this call are acquainted with what we do in research and maybe less with our open source projects, I want to take some time before we dig into the actual technology to really explain the difference that we have between open source projects at the Eclipse Foundation and the concept of working groups. And those 2 things are really different. So open source projects at Eclipse are really about a group of committers coming together to work on a code base, okay? And this means essentially that our projects, open source projects, and even our specification projects are really about a group of people that come together and self-organize as a self-contained meritocracy. And by that, I mean the meritocracy aspect is really important. You know, you don't become a committer on an Eclipse open source project without demonstrating that you can contribute to the project. So typically, this means that if you want to join an existing project as a committer, you need to build a history of contributions that are recognized by the existing committers. And only after a few months, once you have built this history of contributions, then you can be elected as a committer. But really, our open source projects, you know, they have a project lead, they have the committers, and they decide the technical direction that they want to go towards. You know, the foundation staff are there at the Eclipse Foundation to provide services to open source projects and to support them, but in no way I have any authority over what they do. So we have 50+ projects in the IoT and edge computing space, and I'm not there to tell them what to do. I'm there to support them, to accompany them, and to provide, of course, advice if they require so, but ultimately they make their own decisions on their own. On the other side, there's the concept of working groups, and working groups are really gatherings of organizations, whether commercial or not. So we have plenty of academic institutions, research institutes that are members of the Eclipse Foundation and members of its various working groups. And really, this is about coming together, having a shared vision, decide on strategic initiatives and execute on them. So the relationship between projects and working group is completely decoupled in the sense that open source projects at Eclipse decide which working groups they interact with, and working groups decide which projects are relevant to them. And this is a many-to-many relationship. But all of those things are built onto the core values of the Eclipse Foundation, which is about transparency, openness, and vendor neutrality. So this is really important because everything that we do is public. Everything that we do is in the open. As you will see, there are quite a few examples in this presentation of such things. So this is our IoT architecture that we use in the IoT and edge computing domain at Eclipse. Now, one thing that I should emphasize about this is that this is just a representation that we agreed upon in the community. And when I say we, it's me working with the community members to figure out what should be there. But in no way this is mandatory, or in no way what I'm talking about today is a completely integrated platform with components that are, you know, built together on the same release cycle and things like that, okay? We are at the Eclipse Foundation in the IoT and edge computing domain, we are building a toolkit, a set of building blocks that you can leverage in order to build a more comprehensive platform. But we are not delivering such a platform out of the box, you know, with one single installer, click, 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 and everything is pre-integrated. That's not the point. Our members are building platforms like that in the commercial space, right? Using the building blocks that we have in open source. And so our focus is really to have those building blocks in the best shape possible with the most suitability for their own dedicated purpose. So as you see, the toolkit that we have covers everything from constrained devices, you know, the type of device that you would deploy in the field on battery power, maybe using sensors and actuators, all the way up to IoT cloud platforms, and of course with edge computing in the middle, since it is a very useful middleman in providing specific features inside a broader architecture. And on the second slide, you see the logos for the 20 to 25-ish most active projects that we have in the IoT and edge domain. And really, the point there is not for you to squint over this slide and try to figure out which logos are where, but really to impress on you how comprehensive the toolkit that we have is. Of course, some pieces are more mature than others. Some of those projects have more contributors than others. But ultimately, we feel that what we have at Eclipse is literally the most comprehensive IoT and Edge toolkit that you can find in open source at this point in time. So let's focus now on the type of technologies that we find in the scope of Eclipse IoT. So Eclipse IoT, as I mentioned, is our oldest working group at the Eclipse Foundation, nearly 12 years in the making. And really the goal there, as I said, is to provide you building blocks to build IoT platforms and solutions. So of course, plenty of those platforms and solutions are commercial because we have lots of commercial organizations in our membership. But as I said, we have a number of research institutes and academic institutions that participate as well. And so, you know, everyone is really welcome to contribute and use, of course. So this is the current membership for Eclipse IoT. So at this point in time, we have 3 leader members. So that's Bosch, Eurotech, and Red Hat. They contribute additional money to the working group so that we can deliver services to our projects and support the staff, like me and my dedicated marketing manager and other people, of course. And then we have innovator members that you know, contribute to our budget and you know, have a stronger investment than some of the other members in our platforms. And then you have the rest of the membership. And as you can see, we have little startups like Aloxy. We have smaller organizations like CirrusLink and Inductive Automation. We have very large members like SAP, Deutsche Bahn, and IBM, and everything in between. And of course, research, you know, institutes and academic members as well. So one good way to start digging into the Eclipse IoT toolkit is really to start with this base layer of protocols. So if I go back to our architecture, you will see that we've got open source hardware at the very bottom as a kind of a foundation layer that we are doing with Open Hardware Group, then security, and then connectivity and protocols. And really, it's a good starting point to explore the ecosystem because essentially they tie together every of the layers that you could have in the architecture. So that's why in this presentation, I'm starting with that. And really, in terms of established protocols in the IoT and Edge space, we've got extensive coverage for every widespread protocol that you can find in the market right now. So whether you think about CoAP, DDS, Lightweight M2M, OPC UA, or MQTT, we've got projects in each and implementing each and every of those protocols right now. And most of them are among the most mature that we have at Eclipse in their particular domain. So Californium has been around, I think, for example, since 2014, Cyclone DDS since 2016, etc. And so in some cases, we have only a single project in the space. And in some instances, we've got 2 or more. So for MQTT, for example, we've got 2 brokers, Eclipse Mosquito, which is available in nearly any Linux distribution, and Eclipse Amlin, which is a contribution from IBM, which is a highly available, clusterable, clusterware type of broker. So, you know, a different type of deployment. And both of them coexist because we don't discriminate, you know, at Eclipse. We are not picking winners. You as consumers and, of course, the developers are selecting which projects are relevant to them. So it's no wonder that in some categories we have several projects because ultimately we are not the ones deciding. As long as our projects follow Eclipse rules of engagement in the Eclipse development process, you know, multiple implementations of the same thing are welcome, and they are all supported in the same way by the staff. So for MQTT, 2 brokers, and then the Eclipse PAHO collection of clients. So MQTT client implementations, you know, in various programming languages. Now, looking at some of those protocols in greater detail, if you are less familiar among them and you're not sure which one is the correct one for your project, CoAP, and I'm going through them in alphabetical order. Don't don't think that because I'm talking about CoAP first is necessarily the best option. So CoAP has been defined in an RFC, and it's a request response protocol that can run on UDP or any UDP equivalent. And really, it's well suited for connectivity among devices on the same network, but between devices and the internet, and even among, between devices on different networks bridged by the internet. And so the CoAP interaction model is really exactly like what you get when you do REST web services. So, using verbs like get, post, put, and delete in order to define semantically meaningful operations on a service, and really everything that about HTTP, translates directly into CoAP. So URIs, response codes, MIME types, and things like that. One characteristic of CoAP is that it will use multicast in order to perform specific operations. However, test that on your network, because most network admins don't like multicast, because it's a good attack vector for denial of service attacks and things like that. And you need proper support at the network level if you want to leverage that in CoAP applications. So be careful there. So CoAP, really is a synchronous protocol. So yes, it's request response, but the requests are asynchronous, and eventually you will get a call back when you get the response back from the service. It's got low overhead. Everything is very simple to parse. It supports URI, content type, and everything. So let's say you want to manipulate textual data versus binary data versus images and things like that. Of course, using or leveraging the content types enables you to properly configure the services there, and the way that clients are consuming what's received from a resource. And really, what's great about CoAP is that, of course, if you have proxy and caching capabilities on the network for HTTP, then CoAP devices will be able to leverage that. So this is the CoAP protocol stack. So it will run over IPv4 or v6. And of course, UDP is the transport. And instead of plain TLS, which is a bit too heavyweight for constrained networks, there's DTLS, which is a version of the TLS protocol, but optimized for bandwidth constrained networks. And really, what's interesting there as well is that you can run CoAP over Bluetooth or non-IP networks. And the way this is done is that you will establish a Bluetooth or a personal area network implementing 802.15.4, and then you deploy 6LoWPAN over it. So this provides you IPv6 connectivity over a non-IP network or physical channel. So this is really an interesting capability there. So Eclipse Californium is our implementation of CoAP, and it's really, really complete in terms of the feature set. It implements even some experimental implementations for CoAP over TCP and the object security for constrained RESTful environments and things like that. So really a well-maintained project, very much alive, and certainly well worth your attention if you're looking into CoAP. Next comes DDS. So DDS is a completely different beast. CoAP is request response and asynchronous. In the case of DDS, it's a publish subscribe protocol that supports peer-to-peer connection between the nodes. So there's no concept of server or resource or broker. This is a bunch of nodes communicating on a network. And any node in a DDS infrastructure can be a publisher, subscriber, or both simultaneously. It's already very popular in many verticals. It's been around since the early 2000s. So aerospace, defense, air traffic control, autonomous vehicles, medical devices, robotics, plenty of interesting use cases there for DDS. And the spec is owned by the DDS Foundation, which is affiliated to the Object Management Group. So DDS provides complete decoupling between the participants and the nodes into a network through the concept of a data space. So, you know, it's a bit forward thinking there, because we are talking increasingly about data spaces, you know, in the IoT and Edge space. It's completely decentralized, so there's no single point of failure. So this could be of value of you. And it's got a very granular set of quality of service policies that enable you to express specific constraints about the infrastructure. From that perspective, it's quite interesting and flexible. What's great about DDS is that you have automated dynamic discovery of the nodes in the local network. So you don't need to pre-configure anything. You start a node and then you start a second one. They will find each other through automated discovery. Now, of course, this generates a bit of traffic. So, you know, this will consume resources. And the other problem with DDS is that it's great for a self-contained network or even a field area network. However, if you need to bridge different locations through the public internet with DDS, it's a bit painful. You can do it, but you have to encapsulate the traffic, and there are complexities there. So that's not necessarily your best choice if you want to achieve that. So this is a protocol stack, so really straightforward. The DDS, you know, has two distinct specifications to define the transport protocol. So that's RTPS that you see there on the top of TCP and UDP. And then there's the actual full-blown protocols, so to speak, the publish and subscribe interaction on the top. Our implementation of DDS is Cyclone DDS. It's a pure C implementation, so it's highly portable, and it's got really a minimal set of runtime dependencies, so that make it really attractive for a wide variety of environment. It's quite compact, so you can squeeze it in as small as 520 kilobytes of memory. It supports multiple platforms out of the box, of course, Linux and Mac OS, but Windows as well. And it's a tier 1 middleware in ROS2, and it's the default DDS implementation used in the robot operating system version 2. So a great piece of technology with quite a good market adoption there. Going forward with another protocol, which is lightweight M2M. So lightweight M2M is using typically CoAP, although you can use other transports with more recent versions, but really it's a protocol designed with higher level functions than the alternatives that we've seen up to now. So it supports sensor networks and machine-to-machine environments. And really the focus is on lightweight, low power devices with a rich set of predefined APIs, an extensible model, an extensible resource and data model. So essentially what they are doing, there's a core spec for the protocol itself. And then the owners of the spec, OMA SpecWorks, what they are doing, they have a registry of predefined resources with predefined structures that you can implement. And if you implement something that you feel is interesting to the community, you can submit your own resource definition to the kind of library that OMA SpecWorks maintains. And if they accept it, then it becomes part, let's say, of the officially recognized set of resources that lightweight M2M implementers can use. One interesting thing about lightweight M2M is, as I mentioned, it's really a higher level protocol. So of course, it will provide you everything that's in CoAP and other protocols that are request response, but really it provides things like bootstrapping for devices. So there's the concept of a bootstrap server that when you connect a new device, it will contact the bootstrap server and then get its credentials for security and its security certificates from the bootstrap servers, and then auto-configure everything itself. And after that, being part of a specific architecture or infrastructure. Lightweight M2M also provides you ways to manage device configuration, firmware updates, fault management, and all of those things. So as you can see, we are a bit higher in the stack there, in the sense that this is not just about resources or low-level requests and responses, but really there's a deliberate intent to provide facilities to developers to support the easy deployment of devices in the field. So this is the lightweight M2M protocol stack, at least, if you look at the newer versions. And as you will see, there are many more transports available compared to plain CoAP or just DDS. And you even have the opportunity to run lightweight M2M interactions over text messages, for example, and directly over LoRaWAN types of physical links, for example. So quite interesting, quite comprehensive. And here I'm showing a slightly older version of the protocol stack, but in newer versions, it's theoretically possible to have MQTT, for example, as a transport instead of CoAP. So in the middle of the stack. Now, that's a possibility that's documented in the spec, but to my knowledge, no one in the market has, at this point in time, an implementation of the concept of CoAP over MQTT that could be something that you can deploy straight away. So it's still an emerging implementation, let's say, of the protocol. So at Eclipse, we've got two projects that implement lightweight M2M. So Eclipse Leshan is a Java library for implementing clients or servers. So it's not a full-blown solution, but really a set of primitives that you can use in order to add lightweight M2M support to a platform that already exists, or maybe one that you are building from the ground up. It's really simple. It doesn't use any framework, or at least no external third-party framework, and has very few dependencies. And it comes with a web UI, to discover devices and testing. So it's quite interesting. And it's based on Eclipse Californium, since in this case, in the case of Leshan, CoAP is the preferred transport. And then we've got Eclipse Wakama as a C client implementation of lightweight M2M. So if you are targeting smaller types of devices, then it's certainly well worth a look. Of course, it doesn't have the kind of server-side behaviors that Leshan possesses. So typically, many people will using both. So Wakama on their constrained devices programmed in C, and of course, Leshan on the server side. And the last of our established protocols is MQTT. So MQTT has been built from the ground up to connect power-constrained devices over low bandwidth and unreliable networks. Okay, so by default, MQTT will run over TCP, but it uses, there's a distinct version, MQTT-SN, that can run over UDP for environments that wouldn't support the full TCP stack. And initially, it was targeted in the case of MQTT at SCADA use cases. So really industrial automation and things like that. So historically, MQTT has been invented by Alan Nipper and Andy Stanford Clark, and they were working together to automate oil transport pipelines somewhere in the US. And they designed the protocol, to be something that would be lightweight and easy to deploy in field environments. So MQTT uses the publish and subscribe paradigm, and so you wouldn't keep durable data or persistent data over the infrastructure. The goal is to shuffle data around to its destination. And the spec for MQTT is owned by OSS Open. So MQTT provides quality of service. So messages can be delivered at most once, at least once, or exactly once, depending on what you need. Of course, the higher quality of service you select, the more resources you will consume on the server side. And MQTT is a brokered protocol, so you need this central broker in order for the clients to publish or subscribe to messages. It's got the principle of persistent sessions and retained messages. So when a new device connects, if you wanted to receive the last copy of a message that was sent on a specific topic, then retained messages can achieve that. MQTT also features has a feature called last will and testament. So if you want to send a device, if you want a device to send a message as it's getting disconnected from a network, one last message to signify to other nodes, for example, that it is getting offline, then you can do that very, very easily. And you can keep MQTT sessions alive, through the protocol itself. So this is really useful, especially if you are using TLS to encrypt the traffic, because by using MQTT keep alive, even if your device goes to sleep, when it comes back, you don't have to do the full TLS renegotiation again. So especially for battery operated devices, this saves you valuable battery life, because of course the cryptography involved in establishing a TLS connection is resource intensive from a processing perspective. So this is the MQTT protocol stack. So very straightforward, running over TCP or UDP in the case of MQTT-SN, but MQTT-SN, although it's around, is a bit less, quite a bit less mature than plain MQTT. So you will find that there are less open source projects and less commercial implementations on that side of things. So at Eclipse, we've got two very mature projects in the MQTT space. So PAHO is a collection of MQTT clients in several languages, and it's really there's a comprehensive feature set in most of those clients. So automatic reconnection, buffering, message persistence, and things like that. But you have to check for the specific, the details of the specific language version that interests you, to make sure that the features that you are looking for are there. So, most of the most mature clients in the PAHO collection support the full feature set, but some of them are a bit more recent and don't support the full feature set. But there's on the PAHO website a table that gives you that information in detail. And then from the broker perspective, there's Mosquito, as I said, very popular, available in every Linux distribution or close to, and a very lightweight broker that you can deploy even in resource-constrained environments. We also have the Eclipse Amlen broker for cluster-aware, highly available types of deployments. And in the case of Amlen, what makes it interesting is that it's got a bridge with the JMS protocol, which is very popular in Java Enterprise types of deployments. So you can bridge MQTT with JMS using Amlen, and it's been a contribution made by IBM. Essentially, Amlen was the core broker in IBM Watson IoT, which is getting discontinued, but Amlen continues. It goes on as an open source project. And it's a very mature, very powerful broker that has been worked on from a code perspective since 2014 or something. So, quite, if you need to process millions of MQTT messages per second, then Amlen is certainly your best bet. Now, we are looking at or moving up the stack. So we have explored various mature protocol implementations, but we've got a number of projects that are built together, tested together, and provide you a fairly comprehensive stack on their own. So the first one of those stacks is the gateway, what I call the gateway and devices stack, and it is made of the Eclipse Cura and Eclipse Kapua projects. So Eclipse Cura is a fully featured solution for IoT gateways. So it's written in Java and uses the OSGI packaging technology or packaging conventions. And really what it does is that you install Linux on your hardware, you install Cura, and then you have full support for MQTT and other protocols out of the box. It will support Wi-Fi, Bluetooth connectivity, and it comes with a graphical user interface to configure and manage everything. So really a very mature, well-thought solution for gateways in general. And then if you need to administer remotely those gateways, you have Eclipse Kapua, which is an IoT cloud platform to do that. So it's a modular IoT cloud solution that really manages Kura instances in the field and the data that comes out of them, okay? And really together, they are a comprehensive solution to achieve that you can deploy on any cloud. So this is the basic architecture for Eclipse Kura. You will see in there, their support for a variety of wireless connectivity solutions in the drivers. And when I say wireless, their support for wired protocols as well. So you can use the standard GPIO that you would find in a Raspberry Pi, for example, if you are so inclined. And many gateways nowadays include that, even if they use stronger, more reliable hardware than what you would find on a Raspberry Pi. It's got support for OPC UA and other protocols, etc. So really a comprehensive platform. One thing that's not apparent on this particular slide is the fact that in its most recent versions, Eclipse Kura has gained the capability to manage containers. So if you want to use Kura, but you don't like Java as a programming language, that's fine. You can write your IoT applications in any language you want, containerize them, and run them over a Kura gateway by using the built-in container management capabilities. Also, Kura has gained in recent builds the capability to integrate with popular AI frameworks. And essentially, they started with support for the NVIDIA stack, but their plan was to add support for other stacks like PyTorch and others over time. So I'm not sure where they are in this process at this point in time, but there was a very useful presentation at EclipseCon about their integration of the NVIDIA stack last fall. So I invite you to have a look at the YouTube channel for the Eclipse Foundation, where you can find this presentation from 2022. And of course, they will talk again, they will present again at EclipseCon in 2023. So maybe if you want to go deeper and talk to the team, lots of Eurotech people, which is the main contributor to Kura, will be on the ground. So I certainly invite you to join us at EclipseCon. Another stack that we've got is what I call the digital twins and connectivity stack, and it's made of three main projects: Eclipse Ditto, Eclipse Ono, and Eclipse Hogbit. Eclipse Ditto is a flexible platform for digital twins, so it exposes APIs that you use to create and manage digital twin instances. Okay, and that includes state management and access control. So you've got a full set of security features to ensure that twin instances are only accessible to authorized parties. And really, the state management means that even if the actual devices get disconnected from Ditto, you will always have, the latest version of the data kept at least for a specific duration if you configure to do so before it is purged. Then Eclipse Ono is a connectivity platform, a highly available type of platform that can scale to millions of connected devices. So it's protocol agnostic, so it will support essentially multiple protocols through a set of protocol adapters, and out of the box will work with CoAP and QTT and others, and really is a great way if you have lots of devices in the field to connect to them and manage them at a high level. And then Eclipse Hogbit is a way to plan update campaigns for devices in the field. So you can use it to roll out software updates to constrained devices or gateways connected to any IP type of network. And the three of them have been contributed by Bosch and are still have a number of Bosch contributors to them. So, they were using it in their Bosch IoT Cloud. And we had an interesting presentation at our recent virtual IoT and Edge Days conference back in May, where someone was explaining how to replace Google IoT Core because it's been discontinued by Eclipse or no in virtual machines and running that on any cloud. But of course, you can do that on Google Cloud if you want to stay there. So that's an interesting presentation that you can find on our YouTube channel as well. So it was from May of this year. So just to give you a taste of what's under the hood for Eclipse Ditto, our digital twin platform. So you see it's got connectivity for a wide variety of protocols, HTTP, MQP, you know, the two versions of it, and MQTT. And then it can integrate directly with Apache Kafka infrastructure as well. And really quite a good platform to manage instances of digital twins. Now we switch gears a bit in the sense that we are, you know, we have looked at protocol implementations and stacks and things like that. Now we are getting even higher in the stack in the sense that we are looking at a way to implement proper interoperability between MQTT devices in MQTT-based infrastructure. So if you are familiar with MQTT, one of the great things about MQTT is that you can publish anything to any topic anywhere, right? One of the bad things about MQTT is that you can publish anything anywhere, in the sense that the spec itself in MQTT doesn't say anything about the types of payloads other than to say that you can have a, you know, a text payload or binary payload, and that's perfectly fine. Problem with that, of course, is that out of the box, if you have devices and pieces of software and you want to integrate them, they have no idea what the topic structure would look like in advance. They have no idea how the payloads would be structured in advance. And this means, unfortunately, that, well, out of the box, MQTT devices and software components cannot interoperate. So Sparkplug solves that specific problem. It's an open specification at Eclipse that defines a set of standard payloads, a set of, you know, well, a topic namespace, so a specific structure for the topics where devices and software components are expected to find their place, and then a stateful session management, so you don't have to use polling and response to figure out if devices are online or not, okay? So by providing these three things as a spec, Sparkplug enables interoperability in MQTT-based solutions. So that's the current membership of that particular working group, because Sparkplug is a working group, is a specification, and there's also, as you will see, an open source implementation of Sparkplug available. And as you will see, we've got a bunch of academic members there, the University of Sheffield and Stellenbosch University in South Africa, collaborating to the community's efforts. So Sparkplug, as everything that we do at the Eclipse Foundation, is built in the open. So the specification document and the technology compatibility kit are built, you know, in one repository. And so that's the one that you see on the left. And then you have the Eclipse Tahoe project, which is a fully compliant implementation of Sparkplug on the right, in its own repository as a distinct project. And the thing there is that, well, there are plenty of implementations of Sparkplug that don't use Tahoe, but if you want to implement it quickly, then Tahoe is certainly the quickest way to do so. The great thing about Sparkplug is that really, you know, it's a truly open specification in the sense that it's built in the open and anyone can implement it. So really anyone can, you know, download the spec document free of charge without being a member of Eclipse. Anyone can use the TCK to validate the conformance of their implementation, and everyone can propose changes to Sparkplug by opening issues or even straight pull requests on GitHub. And really that makes it different from OPC UA and other very popular protocols in the market, in the sense that we do literally everything in the open and we don't require membership for anything. And on top of that, since Sparkplug is built on MQTT, it can go in places where OPC UA cannot go, because OPC UA mandates a server, and that's a heavy process to implement for a constrained device. So typically, most OPC UA implementations will rely on protocol converters and things like that, and the constrained devices in the field will use different protocols. In the case of Sparkplug, you can squeeze an MQTT mosquito broker in a very, very small size on a very constrained device, and this means that Sparkplug can go there as well fairly easily, and that provides an additional level of compatibility. And we offer to our commercial implementers a compatibility program. So, if you rely on Sparkplug, then you can go on our website and look for Sparkplug compatible products to leverage from a commercial perspective. But there's a bunch of open source projects there that are compatible as well. And one of the great things about Sparkplug is that it is literally the first step that the Eclipse Foundation did in the world of international standards. So what we did is essentially that the Eclipse Foundation obtained the status of publicly available specification submitter at ISO/IEC JTC1. And since then, what we did is that we submitted Sparkplug as an international standard. And I have the pleasure to say that back in May, the ballot to approve Sparkplug as international standard was successful. And well, of course, JTC1 is a big bureaucracy, so it will take some more months before it is officially published. But we are getting there. And so in the next few months, you will see a press release coming out of us saying that Sparkplug is now officially known as ISO/IEC 20237. And really the way this works is that we take the straight Eclipse version of the specification document. We submitted that for transposition at JTC1, and then it will be published nearly as is, with just a few changes to accommodate the copyright standards of ISO/IEC in order to be fully compliant on that side. But from a technical perspective, ISO/IEC 20237 and Sparkplug are exactly the same thing, completely comparable. So once again, this is a kind of value that we offer to our community. So when we have specs and standards that are mature enough, we can now submit them as international standards. And we have a permanent liaison with Subcommittee 41 at JTC1. So that's the committee on IoT and digital twin. We are in the process of requesting a liaison with Subcommittee 38, which is the one on cloud computing, cloud and distributed computing. So if you have, as academics, an interest in international standards, and quite a few academics do, given the number of university professors that I met in the transposition efforts for Sparkplug, then we should talk, because certainly Eclipse as an organization is getting more and more involved in the world of international standards. And this brings us to the last segment of this presentation, Eclipse Edge Native. So the focus of Eclipse Edge Native is to gather together people that care about edge computing from a code-first perspective. What this means is that we don't care so much about abstract architectures, but really care about working code, that implement fully featured platforms around the concept of edge ops. So now you will ask me, what is edge ops? So edge ops is DevOps tweaked for edge computing. Why do we need to tweak DevOps at the edge? The answer to that is quite simple. Think about the Autobahn at 4:30 p.m., in the afternoon, or depending on the country where you are. I lived in Brussels, so there was the ring around Brussels that was clogged at the same time. So whatever your country in Europe, or even elsewhere in the world, think to your favorite, always, your favorite highway that's always full of traffic jams, right? So, of course, if there's a huge traffic jam, in the middle of the afternoon, or as people are getting back home after work, that's not the right time to patch the connected cars on the road, that's not the right time to patch or to send a new version of the software for the connected roadway infrastructure. So essentially, DevOps is great. You know, the short life cycle, the collaboration, CI/CD, all of those are great ideas, but you need to tweak them in order to be effective at the edge, because edge computing is a different game than plain IT, right? And so Edge Ops is DevOps, but tweaked for the edge by taking into account the challenges that edge computing helps you address, you know, reduce latency, reduce bandwidth consumption, etc. The characteristics of edge computing projects, the longer lifespan of the infrastructure, heterogeneity, etc. And of course, the specific deployment modes of edge computing. And all of that, this means that you will do lots of DevOps-ish things, but with a in a slightly different way. So for example, you would do continuous integration probably, but you wouldn't do continuous delivery, because you need to wait for the proper time in the day, for example, to send your patches in the wild. So we have several edge projects. So I put the most active ones on this particular slide. So IOFOG is an edge computing platform that relies on a centralized controller, and that controller will be able to manage containers on nodes wherever they are in the world. So essentially, there's a network proxy in IOFOG that enables you, without a VPN, to deploy nodes on any network and to bridge them over the public internet. So a great platform for container orchestration. Then there's Eclipse Canto. Canto is much more recent than IOFOG. IOFOG has been around since 2016. Canto is much more recent, but Canto is also container orchestration at the edge, but with a twist on specific functional features, in the sense that, for example, Canto will provide you a file upload service. Okay, so this is something you would need to code on your own if you wanted it on IOFOG. So in the case of Canto, it manages your containers and then has some specific features like that that are available in the infrastructure. Of course, since Eclipse Cura can manage containers, you can use it as an edge compute platform as well, not just as a gateway. And then there's the Eclipse Zeno protocol, which is really interesting. So essentially, see Zeno as a modern version of DDS that fixes the weaknesses in DDS. So it's a publish subscribe protocol, which is able to bridge the public internet really easily, because it's got the notion not only of peer-to-peer communication like DDS, but it's got routing nodes in there as well. So essentially, you deploy routing nodes in a Zeno infrastructure. And well, I'm skipping on some content there since we are getting shorter on time. But really, in the case of Zeno, what's interesting about it, and you see it on this slide, is that those routing nodes enable you to bridge together peer-to-peer deployments in some locations with pure clients. So clients are smaller devices that cannot support the full peer-to-peer, but can connect to a neighboring peer or a neighboring routing node. And using those routing nodes in various locations, you can bridge the public internet and have infrastructure spanning the whole globe if you want to do so. So in this case, we are showing robots deployed in Canada and France, for example, and you see the selectors for those various pieces of infrastructure. And on the top of it, Zeno integrates the notion of geographically distributed storage. So you can have databases, SQL, NoSQL, in memory, whatever you need, in specific locations that will gather data over time. And then you can run queries over the Zeno infrastructure in order to get historical results, you know. So that's really interesting, because most protocols care about data on the move, but Zeno tackles data at rest as well in databases by supporting pluggable databases on routing nodes. And really, this is a little diagram that comes from a white paper that we published on 2021 on Edge Ops. And really, the logos in color come from Eclipse. The logos that are grayed out are other interesting projects in the edge computing space. And here, what you see is that, you know, from on the edge to cloud continuum, on the DevOps continuum on the other side, Eclipse projects are all over the place, well distributed over those two continuums in the two dimensions. Whereas grayed out projects from the Linux Foundation, for example, like CubeEdge and K3S and things like that, are clustered into specific parts of the matrix. And this highlights that Eclipse is pretty much about providing solution to developers and application you know, management targeted platforms. And elsewhere, like the Linux Foundation, you will find much more infrastructure, and we integrate with that. We are not in the business of replacing Kubernetes or anything. We are about building platforms that complement what you can find elsewhere. So that's it for now. So lots of materials that I had to cover, well, quite fast. Thank you so much for sticking out towards, well, until the end. And there were no questions as we were going forward, but if you have questions now, I'm happy to stay for as long as needed to answer them. So thank you so much, and don't hesitate to get in touch with me. And of course, visit our various websites if you like to learn more about specific parts of the stack. Thank you.
Thank you, Frédéric. Yes, there were no questions during the presentation. I don't know if we have some question now. I think it would be great if we clarify how do we can engage with the Eclipse open source project in IoT and Edge computing space. So we can clarify this. So if someone wants to engage this.
Yeah. There are various ways to engage. So first, for Eclipse IoT, for example, we have a monthly call of the community, not just for Eclipse members. So if there are people listening to this webinar that want to join, then the invite is on a public calendar. I can share that with them, and they can come and listen to, well, what's happening in the ecosystem, but also request to present, for example, about their research projects, for example, to find new partners or get new ideas or get feedback from industry people. So that's, you know, the basic level of engagement. Above that, of course, anyone can make contributions to Eclipse open source projects. Okay, wherever you are an academic, wherever you are from the industry, we are open to all contributions. And the best way to do that is on the GitHub or GitLab repository for the project that interests you. So you go there, you open issues, you even propose pull requests or merge requests on GitLab. They have a different name, but whatever. You come with your ideas and start a dialogue like that with the actual people working on the code. And if you do that sufficiently often, then of course you can eventually get elected as a committer if you like. That's another thing that you can do. And it's the same with Sparkplug and Author Eclipse specifications on the spec side. So if you have proposed changes or ideas, you can come there. If you just want to have a conversation, maybe you're not ready to contribute code or things like that, then what you can do is, of course, join our mailing list or Slack workspaces. So we have a Slack workspace for Eclipse IoT. We have one for Edge Native, we have one for Sparkplug. So all of these are open to anyone. So I can provide you the invite links, and you can have a direct conversations with the community there. And we have mailing lists for various things as well. So, you know, lots of ways to engage. And if you're not sure, come to me. I will guide you and introduce you to the right people. That's my job, to make it easy for you in the research community to interact with our open source projects.
Okay, actually, on this topic, we have a question that has been shot in the chat. I don't know if you can read the chat, otherwise I will read the question for all the audience. I
can read it. I can read it.
Okay,
so
okay.
The question from Ryan, and thank you for your question. How would you recommend getting started with Eclipse IoT? I am currently looking at Hono plus Ditto. Is this a good place to start? I am trying to build a sort of IoT platform to connect sensors to a wide range of applications. So the answer to this question is yes, this is certainly a very good combination to look at. Ono and Zito are meant for the kind of project that you have in mind, Ryan. So an easy way maybe to get started with this combination is to have a look at the Eclipse IoT Packages project. So let me type that in the chat. Eclipse IoT Packages. So essentially, Eclipse IoT Packages is a small project where people are working on Helm charts for Kubernetes that provide you pre-integrated, pre-configured combinations on some of our projects. And one of those packages is Ono and Zito and some other things around to provide you a kind of starter environment to kick the tires. So if you are comfortable with Kubernetes, that's an easy way to set up an environment and get started with that particular combination of projects. Really, that's the easiest way to get started. Otherwise, then you know, each of the projects have getting started instructions in their documentation that you can use to deploy your own instances, or alternatively, well, there's a shortcut there as well. I'm covering some of that, at least at a high level in the book. And if all else fails, please reach out to me and I will put you in touch with the right people that could help you if you run into problems, Ryan. But thank you for your question.
Okay, thank you. Thank you also, Ryan. I think we don't have other questions, or if you have, now is time, but we don't have other questions, so we also are on time, more or less. And I want to thank you again, Frédéric, for being here, and all the audience. And I hope you all enjoy that. So thank you.
Thank you, everyone. Thank you, Rosaria, for the opportunity. And maybe one last call to action here is really, we presented this to you today because we want you to focus on cutting edge research. Don't waste your time reinventing the wheel. You have building blocks that you can use very easily to build your platform and then innovate, you know, and do cutting edge research at the top. So my recommendation is really to focus on what you can do at the top, so to speak, and rely on our building blocks. And if you're not sure what to use for your project, then I'm there to help. I can help you navigate the ecosystem. And the other dimension is that, of course, we wish your research projects to be successful and ultimately to become eventually Eclipse open source projects as well, if you have, you know, cutting edge discoveries and research that you do. And that's something that the research team can help you with. You know, Rosaria and Marco and Philippe can provide you guidance about how to be successful at that. And then I take over and help you to be successful as an open source project. So we are one big team to help you out. And so don't hesitate to reach out to us.
Yes, that's a perfect overview. I also would like to remind you that all the presentation will be available online. So you will also have the link there. Okay.
Fantastic.
Yes, so thank you again and have a nice day, guys.
Thank you, everyone. Take care.
Bye.